I started working with a new product here that came to Gray Digital Arts. This is a customer submitted PCB for a hand controller for OnStep. This one is being called the Smart Hand Controller 3.2 MJS, and I'll show you some of the differences or features of this PCB. The first thing that really stands out is the length. The PCB is much longer than some of the other past smart hand controllers. It makes for more room for components and features, and a little bit better fit in the hand. But you can also see it uses the 1.5 screen, much like the other smart hand controllers. It uses a backlit or non-backlit. Right now I'm only stocking the backlit ones. I got some buttons. They actually have LEDs in the back so that these arrows light up. And the OK, the center button. You can adjust, it's kind of interesting, each individual button you can adjust the brightness, and you can do that with these resistors down here. They're through-hole resistors. Right now I have 2K resistors in each one of them, so they're all lit the same. I did it for a little bit more brightness so it'll show up on video and such, and maybe out in the field if you're under super dark you want them a little bit dimmer. Another option on this kind of topic that he has on the back is there is a method to follow the same brightness settings. Remember, we have these map LEDs up here where you can adjust the intensity of the map LEDs. Map reading, I guess, is the term I'm trying to think of. That's what they've always been referred to read maps as you're doing stargazing. You can adjust the brightness of these. Well, if you solder this jumper pad, the LEDs on this will follow the brightness commands of the map reading. And I think I'll have to find out the recommended resistors to do that. I do know they're higher than 2K. I think 47K. I will have to look that up, but understand, you know, each one is individually addressable with a resistor. The more resistance you add, the brighter the LEDs get. As you move down, you know, if you go to 47K, they'd be dimmer than these 2K resistors. So that's some of the LEDs and buttons. It's all surface mount components for the most part. There is a handful of through-hole. The one thing that everybody's been dying for is USB-C. It's a very popular format for things now, and USB-C is an easy connection that's you can reverse it. There's all kinds of advantages to the USB-C size USB port. So USB, while we're down here, there's also a BME sensor. That's SMT, surface mount technology, soldered onto the board. So you can take advantage of having this read your temperature, humidity, dew point, that kind of stuff. So the one thing I have found right now, this only works with OnStep X. The weather data does not. It kind of works. So we'll see where that goes in the future. If OnStep 4.24 will be able to support that. If not, OnStep X is the way to support the weather information off the smart hand controller. One thing, you know, a lot of people kind of don't like it because it's near your hand, and your hand is 98.6 degrees. So keep that in mind if you're going to be gathering weather data off of the smart hand controller. Okay. It uses either ST4 power in to supply power to the PCB, or you can hook up a battery. a LiPo battery connects in. One comment about the LiPo battery connector is that it follows the standard, what is commonly called remote control battery format, where it's oriented with positive is on the right, negative is on the left when you orientate the indexing of that cable. So this is something to be aware of. There's a lot of, I know Adafruit flipped it for some reason, where a lot of her PCBs flip the remote control format. But most batteries that you purchase from Amazon with this little 2.0 space connector, they will be this orientation. The positive will be on the right and negative will be on the left, with the indexing plastic on the top here. So when you plug it in, you're indexing to the top, positive on the right, negative on the left. Let's see, we'll continue on. There is ST4 in if you are using an external guiding mechanism that you want to bring in your guiding pulses. You can bring it in through this. So SD4 power and data to on step, SD4 data in from an auto guider, external auto guider. I think they're kind of falling, well, I won't give my opinions. It seems like PhD seems to be more popular, I'll just put it that way. So let's see, map reading is still there, LEDs. There's a lot of stuff on here that is over my head, as I am not a PCB designer. I'm more of a component connector inside PCBs. Let's see, so standard buttons for that. Buttons, and now this switch is kind of unique in that it is a lock switch, in that if you press it in, it'll be in this position, and if you press it, it comes out, it'll be in another position. This is what's deciding how to route the power. If you want battery power, it's one way. If you want SD4 power, it's the other way. Thus, if you only have one power input, it works as an on-off switch. If I only have ST4 and I choose, I can't remember which way it is, ST4, then the other orientation of the switch will be off for SD4. If I have battery, one orientation will be on for battery power, one orientation will be off. This also has the charging component to charge your batteries right in the case. So that's the PCB. I'm sure I've missed a lot. There's more information on the website, and there's a link to the PCB design and everything on the website also. It's got an external antenna, so you can kind of place that if you are using any kind of metal case or whatever. You can place that external if you so like. So let's go ahead. This one is programmed for ST4 power. Right now you have to decide when you upload your code to the microcontroller if you're going to be using ST4 or battery, or Wi-Fi, I'm sorry, Wi-Fi. ST4 or Wi-Fi. So this can do ST4 communication or Wi-Fi communication. I'll plug it into the ST4 port of this PCB over here, and you'll see we've got power on. The buttons light up, and we're starting to boot up. We'll go ahead and show it real quick. So the other orientation of the button is power off. So power on. Looking for on step. And it was able to connect to on step. So from here, we're able to use the buttons. So far I've been able to test the display brightness, or contrast they call it here, all the way to max, and I haven't had any power issues with the OLED dropping connection or anything, or the board. This is a buck boost. So it's not just a 5 volt down to 3.3, it does more than that, I'll put it that way. If I go any more details, I'll be in over my head. So far, power as I've been working with it has been very consistent. I usually set it to min. When you're outside, it can get bright. Hopefully we can see the brightness of the keypad. Let's see. So that's it. So these are your F1, F2 buttons, and these are your standard buttons. So I think that's all I really wanted to show with ST4. So let's unplug that. And this smart hand control over here in the case is set up for battery and Wi-Fi. So there's a on-off switch, obviously on the bottom that works into this case. I went with a pinhole right now display of the charging. Just to reduce brightness. This may change. I made it pinhole because it's easy for anybody to print this. They don't need a 2-color printer or 2-filament printer, dual head, or whatever you want to call it. So we will connect. This is on step 4.24 that we're going to connect to. So and my Wi-Fi is called on step. So we'll connect to the on step Wi-Fi network here. So it was able to connect to the Wi-Fi signal of this PCB, and now it's looking for on-step on that the default IP address. So connection okay. We're again able to go in and do our thing. In the past, I've found battery power is well, I won't say that. It's very convenient battery power. The charge on this lasts quite a bit depending on what size battery you put in it. This particular case, I was able to fit a larger battery than some of the others are being used, but it is not necessary to go to that size battery. So I've been pretty happy with the use on this. I like the screen size. The 1.5 is better than the 1.3. I think it is the smaller one that's on most regular smart hand controllers. So anytime you bump up to that little bit bigger, it's just a better format, a better viewing experience. The power needed for the larger is well supplied by ST4 and battery. So that's about it. But yeah, I'm excited to keep using it, to experiment with it, and as things change, I will update the website and update probably the videos. But so far, this is looking at a very, very reliable design. I like some of the features that was brought to this design as far as the buck boost. There are more features. You'll have to read the documentation as far as the power supply type. So those with more electrical engineering experience can learn more about some of this stuff that he has built into this. But so far I've been very pleased with the usage of it and the experience of using it, and it's been a great design. So with that we will call it a video.